In this video, a follow-up to one we made previously finding horizontal tangents, we're given an implicitly defined function as well as its derivative, defined in both terms of x and y. And now we're going to look for the vertical tangents. So first, let's look at the graph and identify how many we would expect to see on this graph. So our vertical tangents, it looks like we'll have two of them here. One there and one there. We'll also expect to see one over here. So it looks like we'll expect to find three vertical tangents. Now a vertical tangent is going to occur any place where the derivative is undefined, which is going to be where the denominator is 0. So what we're going to do is we're going to set that denominator equal to 0. So y squared minus 1 times y minus 2 plus 2y squared times y minus 2 plus y times y squared minus 1 equal to 0. And those terms can be simplified, and what we get is a cubic equation that is 4y cubed minus 6y squared minus 2y plus 0 equals 0. And we're going to use some kind of computer algebra system to solve this, either Maple or GeoGebra. You could use your graphing calculator or Wolfram Alpha. And we get three zeros. Y equals 1/2 and 1 plus or minus square root of 5 over 2. So we get three y values, which corresponded to our three tangent lines we expected. And clearly we can see the one at 1/2. These are nice and symmetric, so here's going to be the 1 plus rad 5 over 2, and the 1 minus rad 5 over 2 is going to be down here. Now we do need to find the corresponding x values. So let's talk about how to do that for 1/2, and it's going to be similar to what you do for the other two y values. So what we're going to need to do is we're going to need to use the original function with y equal to 1/2. So I'm going to end up with 1/2 times 1/2 squared, so I'm plugging it in for y, minus 1, times 1/2 minus 2 equals what we have on the other side, x times x minus 1 times x minus 2. So what that gives me is on the left-hand side, that simplifies down to 9/16, and the right-hand side, x cubed minus 3x squared plus 2x. This is something that can be solved for x, and we'll go ahead and use, again, a computer algebra system, a graphing calculator. I'll leave that up to you, but we're going to get that x is approximately 2.210, so I'm going to just stop it there. So we would expect to have a tangent line at the point 2.21, 1/2 or 0.5. So let's see if that corresponds to what we have here. We see that x is a little bit larger than 2, and we see that the y is at 1/2. So there's our point right there, 2.21, 1/2. Now again, we would do something similar for the other two y values we got. We would plug 1 plus rad 5 over 2 in for the y over here and solve, and then we'd do 1 minus rad 5 over 2 in for y and solve for x, and those would give us our other 2 points where we have vertical tangents.